Good morning, everyone. Just wait as our honorable speaker is having a network problem. Just wait for some time. Hello, everyone. Am I audible?
Yep, madam, audible.
Okay, just wait for some time. Actually, our honorable speaker is having some network problem.
हेलो हेलो ये नहीं होते कैमरा हेलो प्याली हेलो
Yes, sir.
am I audible?
Oh, yes, sir, audible. Sir, are you ready?
Just 1 minute.
Can I start now, sir?
Yeah, you can start.
Okay, sir. Okay,
You
sir.
can start now.
Okay. A very good morning to one and all present with us today. My name is Piyali De, Assistant Professor of Faculty of Pharmaceutical Science, Assam Downtown University. Would like to welcome you all on behalf of our department to this webinar on optimization of pharmaceutical dosage forms using design of experiment. Now, I would like to provide a brief outline of today's speaker, Dr. Abdul Baki Ahmed. He is presently working as Principal, Girijananda Chaudhary Institute of Pharmaceutical Science, Tezpur, Assam. He has done his graduate, postgraduate and PhD degree in pharmaceutical sciences from Dibrugarh University, Assam. He has guided 2 PhD students and 21 MPharm project students. He has 3 years industrial experience, 15 years teaching and research experience. And he has 3 years industrial experience, 15 years teaching and research experience. He has received Indian Drug Manufacturers Association and IDMAGP NIAD Award, Certificate of Merit in 2000. He has been awarded many national and international conferences and published many articles in national and international journals. Now I would like to take this opportunity to our invited speaker, Dr. Abdul Baki Ahmed, sir. Sir, please deliver your lecture. Please welcome, sir.
Good morning, everyone. Thank you, Piyali. Thank you, all the. Hello.
Sir, please share
Am I
your
audible?
slide. Yes,
Yeah,
sir.
yeah.
Yes, sir. Yeah, you are audible, sir.
And there is. Hello.
Yes, sir.
Is it visible, the slide?
No, sir.
Is it visible now?
No, sir. Not visible, sir.
This is shared vision now, and there is screen.
Sir, here showing US webcam utility. I think, sir, here showing US webcam utility. I think, sir, is the network issues.
Just 1 minute. Hello, Piyali, is it visible now? Hello.
Yes, sir, not visible, sir.
What is It's
Not visible.
yeah, why it is not sharing the screen. Can I get the WhatsApp? I think the system is getting some problem. It is not sharing the screen. What happened? Hello.
Yes, sir.
Kelly, hello. Just I have to exit. I think I'll be joining with from my mobile. Laptop is I think getting some problem. It is
Okay,
not
sir. Okay,
showing
sir.
the screen.
Okay, sir.
Okay, just 1 minute. Take it.
Just wait. Just wait. As our honorable speaker is having a network problem, it will resolve shortly. Just wait. All participants, please wait some time as our honorable speaker is having a network problem. It will be resolved shortly. Okay. Sir? Sir, am I audible, sir? Sir, now your slide is visible, sir.
Hello, am I audible?
Yes, sir, you are audible, sir.
Okay, okay.
Sir, please share your slide.
हाँ हाँ.
Sir, now your slide is visible, sir. Sir, you
Yes.
can start now,
Is
sir.
it
Yes, sir, sir, it is visible, sir. Sir, please deliver your lecture based on your topic, optimization of
yeah?
pharmaceutical dosage
I
forms
think
using
so.
design experiment.
Right.
So now slide is visible, sir. Sir, your slide is visible, sir.
Hello.
Hello? हेलो सर।
चलिए।
हाँ सर।
हेलो।
Yes sir. Sir, you are audible sir.
हेलो।
Yes sir. Sir, your voice is clear sir. Sir, please unmute your microphone sir. Sir, your slide is visible sir. Please unmute your microphone.
Hello. हाँ.
Yes sir.
Now screen. Just one minute.
No sir. No sir.
Yes.
Sir,
Just
no.
Is it?
Yes, sir.
Yeah.
Yes, sir. It is visible, sir. Your sound is clear, sir.
Okay. Okay, I am extremely sorry that I got some technical problem with laptop and this mobile. So anyway, we'll be sharing it from mobiles. If you find any difficulties, please let me know. So first of all, I'd like to thanks Assam Downtown University for giving me this opportunity as a speaker of this webinar. So as we are already late, we'll be directly going to the presentations. So my talk of today's webinar will be statistical optimization of pharmaceutical dosage form. So here we'll be discuss a few of the very fundamental things which will help for our upcoming researchers, M.Pharm or PhD scholars, those who have enrolled. So here, this part is basically will be used students, those who are working in other field also. This pharmaceutical dosage form optimizations, but also it is applied depending on their needs. That is any kind of basic which is the so research data normally is means tools on the data analysis. So here the statistics uh, play means takes an important role for optimizations of different types of dosage form. So when we talk about this optimization of pharmaceutical dosage form, here normally different questions come in our mind. That's what is statistical optimizations or what is pharmaceutical dosage forms we talking about, why it is required these optimizations to be applied in pharmaceutical dosage form, when it to be performed or when it should be done, and how this can be done. So after the end of my talk, I hope that you will get some of the idea how we can apply or we can use this statistical tool for optimization of different type of dosage form. So statistics, application of statistical optimization in pharmaceutical dosage form. Any kind of dosage form, it may be solid liquids or novel delivery systems, where the study can be designed in a proper manner so that we can reduce the cost of the product, we can reduce the time of the experiments to be done to get a ultimate product that will give you the best results. So this design of experiments where the statistical equations or mathematical models will be used to analyze the data, will give us the results which is accepted by the scientific means community. So data of the test and standards are always compared by statistical tools by using different models of analysis so that the results can valid and give a scientific justification. So when we develop a pharmaceutical dosage form, as you know, it is a huge task. We have to go lots of experiments where different factors will be important to consider, and the factors of different levels or which will affect the response of your studies. So the process control, this the factors considerations, selecting products which will give you the best products. All these things are a huge means process or the area where we take spends lots of time, lots of energy, lots of money is involved. So to reduce all this cost, we use the statistical this design experiments so that we can cut down all the other cost, time savings to get a best results out of your possible availables, means resource is available with you. So here in this part or in this talk today, basically, we'll be discussing these very fundamental things which many of our students or the research means scientists are get troubles in designing a proper uh, statistical results of their research. Ultimate products which will give you the best results, very less toxicity or maybe activity which we don't want. So our targets of stable, robust formulations we select from a different kinds of uh, compositions, different kind of ultimately the results or the response of the products. So these statistical designs will help you this problem will be solved. So here when we use this statistical optimization in pharmaceuticals product designs, so normally the three different questions is arises in our mind. So that is how can make a perfect formulations. That means our target always to give a product which is give highest results in terms of the products considered. So normally the compositions when we select, so we take different means these compositions we try and ultimately we analyze the each of the formulations and compare the results and best one is selected. So by scientific way, selections procedures is required to be done. That is why this statistical, this design experts is used. So which analyze all the data of different formulations, what we consider during the formulation developments, and from where we select a best one by applying the design expert software where different types of mathematical models are fitted into data to analyze the data and get out the best one, best product is selected. So we'll discuss this one in these slides or in these presentations to how we can design the experiments, how these different factors will be influence the products, and how we need to analyze the products and how we need to integrate the data into this softwares or this statistical designs and how we'll search for the best formulations. So all of this will be discussed throughout this webinar. So here, first question, how can we make a formulation perfect? So obviously, always we will be looking for the best formulations from the different sources. options or available sources we have. So these questions will be answered. Then what should be the characteristic? That means when we develop a formulations, what we want actually, we will have some objective. Suppose we are preparing a tablet, say taking an examples of a first dissolving tablet, suppose we formulate. So what the characteristics we will want will be, we want that the formulations or the tablet should disintegrate with very in a very few minutes. That means around 2 to 3 minutes. So in that case, what characteristics, first characteristic, important characteristic is that that the tablet should be dissolved within this stipulated time period. What we want. Characteristics, we need to consider the defined condition. That means what type of the ingredients will be used. What there will be considered as a active pharmaceutical ingredients, which will have the therapeutics value. The other substances that we call as additives or maybe agents. So depending on your formulations, you can use different types of formulation. So at what conditions we are working, what is our goal? So that first should be coming in our objective should be clear, or our goal should be clear than goal, basically. So, and here to do or to achieve that goal. Hello.
Yes, sir.
Okay. So when we talk about the optimizations, basically, so this how we can define this optimizations. Here, the different scientists has given the different kinds of definitions of optimizations, which are basically first one is that it means what? It means to produce a perfect or effective or functional as possible. That with that means optimization means what? To make a perfect and effective means a product which will that will be produced from the available sources. So optimization means to select a best product or to make a perfect product which will be effective. Highest if means effective of the product will be there amongst the others means formulations they have prepared. So others has means defined is as to choosing the best elements from the available alternatives. If you have the other similar alternatives of that kinds of your formulations, so this optimizations process means to select the best one. So this optimizations is considered not as a trial and error methods. It is not a trial and error methods which normally you do for the formulation and developments. We try different experiments, we try different changes in the process, we try different changes in the process, we try different excipients to be added in the formulations, different concentration, etc. But in optimization cases, so this trial and error methods normally doesn't means. It is basically the process of selecting the best ones rather than trial and error methods from the experiments what we have conduct. So optimization is considered as a selecting methods but not as a screening methods. So sometimes to produce a formulations, we go for screening by trying different types of designing with different types of excipients, and ultimately we get a products which have the highest if means effective. So effectiveness is very high. So in that case, this optimization process is do not consider as the screening method, but it is a method of selecting a best product out of your different sources or resource which is available with you. So this best one will be selected based on the scientific validated data. So which will be provided by the pharmaceutical softwares. Basically, to select this one, we'll be using the different softwares. So that's different kind of software available. Which will be so when for the optimizations techniques in the pharmaceutical product which we follow for this optimizations technique, one is that means during the study, research study, the experimentation is techniques which is we consider completes before optimization takes place. So second options where the after completing the experiments will go for the optimization process. So two methods: first of the products by continuations of the can be performed, and second one what, that is the optimization will be takes place and should be completed before selecting the optimized batch of formulations. So these two methods, one where we considers as the continuations process, the process will be continuous. Another is where the experiments will be first means completed. So the two methods, first one where the experiments continues is known as evolutionary operations and simplex methods. So here in these methods, basically the experiments allowed to continue along with this optimization process. And second method, basically that is mathematical and search methods where the experimentation is completed before optimization takes place. That means when we'll apply or analyze the data, before that this experimentation need to be done, means completed. So two approach is there. One is where experiment should be completed first before applying the optimization process, and second one is where we can allow the some experimentation to be continuous along with the study is means continuing along with the study process. So these two means methods will normally principles is normally follows in the optimizations methods or process. So when you go for this pharmaceutical optimization of pharmaceutical doses form, there here we face different kinds of problems. So we have the different types of problems in pharmaceutical optimizations of different types of doses form, where one is known as first one is called as the constant, another is unconstant. That means in constant limitations. That means that limitations might be it is a physical limitations or maybe a economic considerations. And second one, that is the unconstant, that is no restrictions is there. Suppose say in case of the constant, if you say, so you need a tablets of manufacture a tablets with hardness around 5 to 6 kg per centimeter square. So here that means the limitation is given that hardness should be achieved 5 to 6 kg per centimeter square, as well as with the hardness the disintegration of the tablet should be completed before 5 minutes. So that is the limitations will means that is fixed with us. So that is when we develop a formulation, fixed constraints are there. So that is called the limit. That is product with a constraints, that is with limitation. Another is unconstant, that means no restriction. It will be disintegration when it will be taking place, it does not mention. So this restriction is not there. So that is called the unconstant. That is more about the results is obtained from the results among the different formulations. We will choose the base problem. But in constant problem, what happens? So formulation should have a particular limitations with you. So you cannot go beyond of that limitation. That is called the constraints. You will need to produce the products, that is called the problems, is known as the constant. That is optimization problems will be considered as the constraints. So there are two problems. One is constraints and unconstraints. Constant means we will have a fixed limits of your results. That's your product should meet the certain your characteristics. But unconstraints means that the products do not have a specific window of limit. So that's you can prepare that products, whatever the results obtained from that, we can choose the best one, which will give you the better therapeutic value of your product. So when we do this optimization of pharmaceutical dosage form, basically we need to consider two different type of variables. One is called the dependent variable, another is called the independent variables. So dependent variables means what? These are basically the responses or characteristics of the product. Suppose say if we consider this fast dissolving tablets or fast disintegrating tablets, in that case the dependent variable might be the different responses. Say suppose say hardness. Suppose that products might have these tablets should have a hardness of certain limits. Suppose say 2 to 5 kg or maybe 5 to 6 kg per centimeter square. So that is a response. That means you are preparing a tablet. The tablet should produce a certain hardness. So hardness is one considered as one response. So that is a characteristics of the product. So another this response maybe that is the disintegration time. So the what should be the disintegrating time of this particular tablet. So whether it is a within 5 minutes, within 10 minutes, or 15 minutes, or maybe half an hour. What is the limits of time of disintegrations? Or maybe dissolutions. So what the percentage of drug should be released within the first hours, or maybe within the first 30 minutes. So that's are the basically we consider as the response. That means what characteristics you want from your product. So these dependent variables are basically will be selected by the formulators. So that will be depends on the independent variables. So independent variable means what? So that's at the control of formulators. So here the researcher or the will select a excipients or maybe any additives or the process parameter can be changed, which are independent in nature. That means they are not dependent with anyone. So that is directly the formulator can have changes on this parameter. But when we change independent variable parameter, so that will reflect the change in your dependent variables. So that is the response of your products are basically depends on the independent variables. So independent variables are those which tablets of your fast disintegrating tablet, obviously. So we'll be selecting formulations. You'll be using the disintegrants to disintegrate the tablets at that faster rate. So these two might be the so binders may be one factors and disintegrants may be the variables in case of a fast disintegration, disintegrating dependent variables also in the design experts, basically there should be a minimum level of the factor, that is the concentration level. Maybe depending on your requirements, it may vary up to the what extent you only used as the levels, different type of levels. So standard levels are used at 3 different levels, that is high level, low level, and that is the medium or average level. So that is the levels used for the independent variable, that is the factors in the design expert. So this part is very important for this designing of the pharmaceutical dosage forms by using the statistical designs. So here the independent variable, what is independent variable you will be select, that is very important. So that will depends on your types of formulations you are going to prepare. So that is depends on your needs. So you can select your independent variable depending on your needs. So that means what you want to do. So based on that, so what will be the independent variable is ideal, so that you must first select. So there, this independent variable, it can have either 2, 3, 4, whatever may be the number. So that's is depends on the formulator. You can choose any independent variable, any numbers at the levels. Also, you can changes according to your requirements. It may be 2 levels, it may be 3 levels, it may be 4 levels, or even more than that. So independent variable means what? Those are ultimately will control the results of your product. So that means it will control the dependent variable, the responses of the product. So if you consider, suppose that first disintegrating tablets, so independent variable might be we select two, suppose say binders 1 and disintegrants another 1, 2. So that means the binders obviously you will be using at different concentration to meet the hardness of the tablet. So hardness will be what? That is the response. First response may be what? That is hardness. So what will be the second response? So response also will be depends, the dependent variable. Number of responses you can select depending on your need. So it may be suppose 2, 3, 4, 5, whatever may be, how many means characteristics you want to control. So that's or you needed. So a simple example of this disintegrating tablet, suppose we consider response 1 will be hardness. So first response will be what? Hardness. You need to maintain a hardness of that tablet with certain means limit. So second will be what? That is suppose a disintegration time. As the tablets will be hard, depending on this, it will change it, means disintegrates into a particular solvents within a certain period of time. So that is the disintegration time, or maybe the time. So disintegration times, maybe the second means response you can select, so that will be considered as the second response. Third maybe that is dissolution, the percentage of drug release from your product. What percentage of result, whether 100% drug will be released within that 5 to 10 minutes, or maybe you want to release 50% of drug within 10 minutes, then remaining 50% maybe later on. So depending on your formulation type normally, so these dissolutions may be considered as another response. So these are basically words, that is the characteristic, hardness, disintegrations, resolutions. These all are basically the response of your product. So which will depends on the independent variable, what I said, that is the binders and disintegrants in these cases. So independent variable, so that is completely will be depends on the formulators. So what independent variables they will use, so that can control by the formulator. But once you choose the independent variable fixed at the different concentration, so responses are normally get changed. So response of this or the in the process of optimization, when we design, basically what we need to consider in the hand of the formulator. And second is what dependent one. So that may be either 2, 3, 4, etc. So or that is the dependent variables. So these things, what is dependent and independent variables. So this is a very important parts of designing of a state means pharmaceutical formulations. So when we go for this optimizations process, normally there are different steps what we should be followed or we should be considered. So first one idea what that is the selective of select the variables. So we need to first step in your work of optimization process is what select of the variables. So independent variable and dependent variable. So as I have discussed means right now what is independent variable and what is dependent variable. So you need to first select what will be your independent variable, and based on your independent variable what are the responses you want to measure. So that is called the dependent variable, that's a response. So after selecting this that independent variable, that means what concentrations or these amounts of this independent variable you will be using in your formulation. So that needs some of the means literature means this idea or this data before selecting the concentration. Suppose you want to use a binders in tablet formulation. So what concentration of binder should you use? So what is whether it is 1%, whether it is 5%, whether it is 10%. So this 1, 5, 10. So this the range of this concentration range need to first select. That means to selecting of this one you need to go for the literature review. So some literature should be first means if you go to study of some literatures, then you will find that that particular that the binders at what concentration it should be used for that particular type of dosage form. So from there you can get an idea of selecting the concentration level or factors level. Suppose whether you will be using the level what will be your minimum concentration or very low level of your factors, and what will be your maximum level of factors. So that's selecting of these ranges basically will give you you can get some idea from literature, or you may go for first the study trial batch of formulations where you can select first this range of your concentration level of suppose that independent variables you will be using. So in case of these integrants suppose as a binders in this tablets when you first disintegrating tablets, so what concentration should be select that should have some knowledge on the formulators. So this is the minimum concentration should be used, and that is the this is the maximum concentration of this should be used. So that idea should have with that formulator. Factors will be used as a binder, and that's at a different level you will be using concentration. Suppose low, high, and medium level. So one factor. Second one will be suppose second factors might be that is disintegrants. What disintegrants will be used? Because for fast disintegration tablets you need to add the disintegrants in the formulation, so that disintegrate the tablets within that stipulated time. So what is the concentration of disintegrants you will be used, that also you will get the idea from the literature or maybe from your trial batch of study can be selected. So the select of this variable, independent variable, is needs that is a independent variable. So once we select the independent variable as well as the level, that is known as the factors. So and the factors, one factors can be used at different level at whatever maybe you want. So that is the independent variable factors, and that is the response, the product's characteristics what you want. So in this maybe it is hardness one response, maybe disintegration time will be another response, maybe either it is 1 2 3 4 whatever the that or you want so to control. So that's will be basically the response. So for first step of objective, you should have select this independent and dependent variables. Then coming to the second means step, so that is what. So after selecting this one, you need to perform a statistical design experiment. That means here, in when we use these design experts for the conducting the experiments, what our objective to use this statistical optimize, I mean this design experts or maybe other statistical tools to use to reduce what's the number of trials. That means in normally, so these statistical designs will minimize the number of experiments. Okay, and the experiments will be means in a proper way or a proper manner. These softwares will use the different means variables, independent and dependent variables. So the designing will be needs will be depends on basically what type of your experiments you are going to do, what how many means independent variable are there, what are the independent variable means concentration level, and what are the responses basically you want. So depends on this we can use different kind of design. So designs in this statistical means designs where different options are there. So the formulator can choose from themselves a perfect or proper designs of these statistical experiments to be conducted. So that is depends on the formulator. So he or she will be design means select this set of design experiments basically based on the number of independent variable he is selected or number of dependent variable has been considered. So depending on these different types of designs are normally means done. Suppose it may be 2 3 factorial designs like that way we consider 2 2 factorial designs, 3 2 factorial designs, 3 3 factorial designs. What are the factors available, what is its level, so that's according to that. So it has a open means options with the formulators in any kinds of designs whatever you want. So select this independent and dependent variables, then experiment need to be conduct. What are the concentrations give a proper design. Here this statistics help us to reduce the time or cost of the product. So here we need to first select what that is the independent to use. So that part we need to select and put in the statistical software. And second thing we what dependent variable. What are the dependent variable and what is its level? Means what are the responses we want 1 2 3 response. So that data need to be put inside this means softwares, and then the softwares when you will run they will give you the exact design of your experiment, what are the different experiments you need to be considered. So that is the part of that is statistical design experiment. So where basically the formulator need to select factors with the level and the responses, how many response you are going to measure. So once we give this data, the software itself will give you the number of trials or number of experiment need to be conducted. And so based on these designs we need to formulate the formulation considering this means design. So what is given by the software. So that is called the designs experiment. So designing this one do not have the limitations. This basically can be varied or selections can be done by the formulator depending on his or her means that requirements what he need basically. So there is the option you can choose any kind of means designs 2 3 3 2 3 3 etc. So that can be done. So once we set this one, that means you will be prepared. So the software will give you the number of trial formulations. Suppose it is a 3 2 factorial design. That means there will be three means levels and two factors. So that means two factors, three levels. So that these two factorial designs. That is 9 formulations will be there. So you need to consider the 9 formulations. What is the composition of this 9 formulation that will be give by this statistical software. So once we to the physical form, that means that they will given as a terms of coded form. So where we need to convert it into that physical units. So designing means converting this physical units, we need to formulate. Then next step we need to do what measures the different property, that is the dependent variable. So once we design the formulations, we manufacture this or we produce this, then we evaluate this for the different responses. Suppose we have chosen the 3 response: hardness, disintegration or dissolution. Go for analysis or measurements of what is the formulation one's means hardness, what will be the dt, what will be the dissolution, etc. So we'll generate the data for each of the experiments which has been given by the designs of the software or design expert, or maybe other software what you will be using for the experiments need to be performed in the lab, and then we need to what considers the responses should be measured. So once we measure the different data of different response will be with you. Along with that data will be then fitted into that statistical software in the design. Different data you need to select the different mathematical equation based formulation. So the based formulation will be predictor equations, which will be are what they are integrated with different mathematical models where the data are need to be fitted. So the your data statistical means models will be given as a analysis reports by the software. So first you need to design the experiments. Then second step you need to formulate those formulation according to the design. Third step what we need to go for the measurements of the different types of variables, independent variable. The responses need to be measured. So once we measure the different variables, then we need to go for predict the equation. What mathematical model equation or statistical model equation will be used for selecting the optimized base of formulation, the best formulation amongst the different means formulation which has been given by this design of experiments. So once we get our data are fitted into that, then the third steps that comes, that is optimize. How we go for the optimizations of the formulation. That means suppose we have used 3 2 factorial designs, 9 compositions will be there, or 9 formulations you need to formulate. Then you will be go for evaluation of this 9 of different responses, all the responses of each of the experiments or formulations will be done. Then you will generate the data, and data will be put into the software and then softwares will be based on the data. Softwares will select for the different kind of models, equations. Suppose it is a linear model or polynomial model, etc., are available in the software, which can be used to fit your particular data. And by after fitting that one, the softwares need to be run, which will analyze the data by the software itself, and it will give you the results. So that result, based on the results, we need to select the best formulation. So the best formulation selection, which one will be the best one. The software itself will not give you that particular formulation which is based on, but we need to select that one based on the different approach or method we can use from the software. So best one can be selected by different methods, so like this mathematical calculation. By using a mathematical equations, the best formulation can be selected, or graphical observation by observing the graphical representation of the data, so which will be obtained from the softwares. Or third option, that is the sources, different source point. That means the formulations of one will be searched for this best one will be selected by search method. That is a point-to-point search method. That is, suppose one formulation will be compared with your predicted value and yes experimented value. So software normally produce some that when we give them based on the data, what will be the according to the composition, which has what will be the predicted value. So predicted value by the software. So if your predicted value is matched regular formulations, so you will get the experimented value. So which will be obtained from the software. So the formulation which comes closer to the formulation means this value of each of as the optimized formulation, normally used in the pharmaceutical dosage form selections. Or we can go for the figures are obtained where the we can consider which will be the best formulation. The different approaches are there for this optimization, selecting of the optimization base. One is what mathematical calculations can be used, graphical observation can be used, or the source point can be used. So these are the basic fundamental things of optimization steps, which includes selective selection of the variables, then performance designing of the experiments, evaluating of the experiments for different responses, and then use of mathematical equations to optimize the data. Then third is that optimization by any of the methods, mathematical calculation, graphical observation, or such methods can be used to select the best one. So this experimental designs, basically it is what it is, a kind of factorial design. So that's factorial designs is basically depends on your independent variables, and based on this independent variable these responses are being determined here. So in case of your this factorial design, so as we said, the formulator can use different kind of design. So if you consider one design, suppose say it is a full 2 3 factorial experimental designs. It means what? As it is 2 is what? That is the level we have used. So that is the superscription 3. That means it is the factor. So that means here will be the 3 factors. It may be x, x1, x2, and x3. So the level means what? The concentration. Only the 2 levels will be there, the high levels or low level. So that's here 8 possible will be there. 2 to the power 3 means what? Total number is 8. So that means in the designs total number of experiments will be what? 8 number of trials will be there. So from this 8 number of trials, one can select the best one depending on the different methods. So we have seen mathematical, graphical, or maybe that is the source point methods can be used. So here the labels means what? That is the concentration level of each of the factors. Suppose X factor, X1 factor is having 2 levels, highest level and low level. So this 2 factorial designs when it says that means there is what 2 levels with 3 factors. So these 3 factors are basically independent variables. So there's do not these are basically in the control of the formulator. So they can choose the factors depending what is the need of their research. So whether what kind of response they want. So depending on the factors, they will choose the responses. So response may be either 2, 3, 4, whatever may be the number. So response do not have the limitation. That will depends on the formulator how many response are required. So to control this response are what controllable means a variable that is a dependent variable, and factors is what that is the independent variable. So that is select by this formulator depending on the need. So here in this table basically it is shown the how the design of factorial design is basically done by the software. So here we have said it is a 2, 3 factorial designs. In the table it is shown that there are 3 factors x1, x2 and x3. So what is x1? X1 maybe your suppose one binder, x2 maybe what is there these integrants, x3 means what it may be additives or polymers which may control the release of your drug substances. So here you can choose x1 maybe suppose as a binder, any kind of binders you can use. In term as a x1, x2 maybe integrants, any these super disintegrants or any disintegrants you can use as a x2, and x3 maybe polymer which can control the release of your drug. So x1, x2, x3. So what will be the concentration of x1 will be used? So in these 2, 3 factorial designs, as it is a 2 levels, basically there will be a what is the highest level? So highest level is denoted as +1 or 1, and the low level is -1. -1 means what? Lower in second will be at a low level, third factor will be at low level. So accordingly, by observing this table, I think you can understand the design that you can go beyond of your limit what you have selected for the different factors level. So -1 and 1. So beyond that you will go the points which will be known as the axial points. So in these cases there is a 3 phase will be there. For each of the phase 2 axial points will be there. So for each of the factor there will be 2 axial points. So there is 3 factor, that means we will have the 6 axial points and 1 center point. 1 center point means all of the factors will meet at a common point, so that will called a center point. So that means 1 center point, another 6 axial points will be there in the design along with another other first 8. So total formulations in this case will be first, that 2 3 factorial design. There are 8 in the trial was there. Then if you want to go beyond of these limits, then you can consider the axial point. So how many axial points will be there? So there will be a 6 axial points and 1 center point. So total number of experiment is added here 7. So total formulation will be how much? 7 plus 8, that is 15. So that means in this design it will be known as a 3 factor composite design. So here the factorial design, it is used 3 factor, but it should be known as what? Composite design. That as we are want to go beyond that box, that means the low level and high level, we want to take more sample which may goes beyond of this one. So that beyond the points of the limits, if you go, that points are known as what? Axial points. So there is a limitation that maximum axial points means percentage of axial point distance. What will be the maximum of axial point? So that is has some limits. But if you want to go for this point with axial point, 7 number of axial 6 axial point, 1 center experiments will be there. So these 15 experiments, the designs you see, what is the difference with the first one? First you are seeing how many formulation? 15 formulation. What axial points? High level, that is for each of the factors there will another is minimum axial point. Along with what? A center or are at 0 level. That means that is a point. So these axial points are allowed where if you want a allowed by this design of experiment. So this is a we have considered the axial points which is shown in this cubical part. There will be 6 representation. So here this 15 means formulation need to be formulated and the data should be generated, then you go for the analysis part. So this is what we consider as the design parts, how we need to design a experiment. Suppose you are having a number of what number of factors and what is the level of factors you are going to do. So that is depending on the factors and labels, the factorial designs are known. Either it is a 2-3 factorial designs or 3-2 factorial design. 2-3 means what? There is a 3 factors 2 level, and 3-2 means what? There is a 2 factors 3 level. So that is the difference we are having. 3-2 means there will be 9 formulation. So once we design the formulation, as per the table it is shown -1 +1 of each of the factors. So that's are what coded term basically given. So in the design, we normally need to give in terms of coded means in terms of code. Suppose highest level will be denoted at -1, +1, and low level will be what at the -1. If it is an average or middle center point, that will be known as 0. So there is a level. If it is a 3 level, -1, 0, and 1. So low, medium, and high level. So in a design experiments, normally we consider these three type of level. So when we design the experiments, that's the experiment need to be changes into physical unit. Physical unit means what's translation of this coded term into the physical form. So if you see here in this design table, is 3 to factorial design. So it is shown in the table. It is clearly means you can understand. So we have used 3 to factorial design. That means there will be the factor what 2 number of factors, and how many levels will be there? 3 levels. So levels are what? -1, 0, +1. So -1 means what? Suppose that is the low level of the factor x. X factor was what? The x are factors are basically what? These are independent variable. That means it is in the control of your of the formulator. So that you can change according to the formulator need. So suppose here this scientist has used x1 as independent variable. So x1 is what? Sodium alginate, and x2 was sodium chloride. Suppose in their study, x1 factor they have taken as a sodium alginate, and x2 they have taken as a calcium chloride. So x1, this factor, what is the level they have used? -1, 0, +1. So -1 means low level. What was the low level? The indicate it is 3 gram. That means 3 gram of sodium alginate was used for the low levels in the design of experiment. In first trial, if you see -1, -1, -1, that means the first formulation will consider one -1, that is sodium alginate here 3 gram, and x2 suppose it will have 2 gram. So the concentration level, so these are -1, 0, +1 means what? These are coded term at low, medium, and high concentration. Low, medium, and low concentration means what? Is used here 3, and highest how much it is used? It is 9. So in case of factor x1, but in case of factor x2, what happened? Here this level is used, the low level 2 gram, highest level it is used 6 gram. So factor x1, x2 is used. Each of the factor used in 3 levels: -1, 0, and +1. That is low to high, and x2 also -1, 0, and +1. Low to high, 3 3s are 9. So there will be 9 formulations, or 9 means the this will be there. R1, R2, R3. So these are what's the R1. They have used the dependent variable. Drug loading biodiesel will be selected based on the this is the characteristics of the formulation. What they are from this different design of experiments. So when you will be having or this formulation, and then you have selected this. So you need to study for each of the formulations for drug release for 3 parameters. So which are known as the dependent variable. So if you change the concentration, it changes. So if you instead of 3, 3% will get changed. So that is why this dependent. So that is the sodium alginate and calcium chloride. So concentrations here you'll find in this second table, we need to change this experimental design into the physical unit. Physically, so we have measured. So if you see here, this as it was 3 to factorial design, that means there will be 9 numbers of means your compositions. So 9 formulations will be there. So that is standard one or run one. So that's this number of standards formulations, and the run total number of run means total number of experiment as per the factor design. So 3 to 9. So total number of run will be 9. So here the first means run will be what? It will be taking as the -1 -1. But that means both are at the low level. So if you consider both x1 and x2 at low level, 3 and 2. Low level -1 was 3 as per the earlier table we have shown. So and x2 was 2. So this -1 -1, that means 3 and 2. If you take 3 gram and 2 gram of sodium alginate and calcium chloride and formulate your manufacture the formulation, then you are need to measure the responses R1, R2, and R3. So these values are basically 63, 69, 97. So these are the percentage drug release, biodistribution, and drug release for suppose formulation 1. It need to measure. This is the experimental part. So you need to measure, you need to find out the drug loading of the formulation 1. You need to find out the biodistribution of formulation 1. Then drug release of formulation 1. Similarly, for formulation 2, as per these compositions x1 and x2, you need to formulate and need to measure these different responses R1, R2, and R3. So for each of the 9 formulated formulation as per the designs, you need to go for evaluating of the all of the responses. So once we evaluate the data, you will have a ready data of this type, and you need to get input of this data into the software. So the software will use this data, input of your data, then they will analyze the data and fit it into different kind of equations. So which will give you the best formulation among these 9. So among the 9 formulations of different composition, which will be the best one, how to identify that one. So to identify that one or to selecting that one, we need to go for the analysis of the data. So that is one, we obtain the data need to be analyzed, need to be experimented by fitted into the different types of the mathematical equations which are available in the softwares. So the softwares will analyze the data and give you the results of each of the formulations, and from the results they will select the best one. So as which one will be the best among these 9, that will be depends on which methods you are using. So depending on the methods, whether it is a graphical method, whether it is a mathematical method, or whether it is a search point methods. So any of the methods can be used to select that best formulation among this 9 experimented design formulations. So when we talk about this data analysis, basically, so what is basically a data analysis? What is mean? Analysis of the data to generate the predictor equation. So first, in the outer circle of this pictorial graph is showing what the outer surface means. What the data need to be analyzed first to get a generative predictor equation. That means the software equation which are fitted into this data. So software are basically designs based on some mathematical. Software will need will suppose if you select in the software, that is data will be fitted. This different type of data will be ANOVA table will be plot. reflect from your efforts to need to be hello. Hello. Clearly,
Yes, sir.
hello.
Your slide is visible, sir.
Uh,
Yes, sir. Yes, sir.
okay. So data analysis, that means once we need to go for the analysis by using the softwares from where ultimately we will be able to select the optimized formulation. So here, first approach or first step of data analysis is to predict the equation, which equations will be fitted by that particular mathematical model, whether it is a linear model or it is polynomial models or These other kind of mathematical regression equations will be fitted of that particular means data what you have given inputs. So here we can select that as if you want a single factors if means effect when we want a single factor. Suppose that is your formulations or the response are factors. So in that case, the linear regression equation can take. Suppose here one type of you have used and these integrants you have used. These or as linear equation repeated your inputs what that is and on this specific mathematical models and data will be generated. So data results of data will be generated into the tabular form. So from where we need to consider the responses whether it will be a significant values or significant changes are there of that independent factors into that responses or dependent variables of significantly or not that will be selected based on your R square value. So when the R square value is greater than 90%, then it is considered as a significant changes in the formulations with that particular factors effects is normally considered. So that data analysis are three step use.
Sir, 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 am I audible, sir? Sir, your voice is cracking, sir.
Okay. Hello. Is it clear now? Hello.
Yeah, yeah, yes, sir. Yes, sir, right.
So this
Now it's
that
okay, sir.
so the depending on your means analysis type of equation you have chosen in the software, whether it is a linear or polynomial equations. So that's based on these selections. So data will be analyzed by the software and it will reflect the results in the form of different types of tables basically. So here you will get the different type of equations. Suppose you have select the polynomial equation, then the different for each of the response you will get a different types of equation, polynomial equation, which can be represented by this equation. Say this regression equations for the polynomial type of data analysis. Normally, they give a second order polynomial form in different means form which is shown as y is equal to a0 plus a1 x1 plus a2 x2. So our second step, so y means what? That is the level of response. Suppose in this study we have as an example we have considered that your response will be what? That is the hardness. So y will be means what? Your hardness equal to will be what? A0. That will be a numerical terms which will be obtained by will be given by this software itself. A value will be given. It may be a positive value or it may be a negative value. Will be there. So then A1 that is the coefficients of your x1. So A1 is coefficient of x1 and A2 is coefficient of x2. So in first line that is equation y is equal to a0 a1 x1 plus a2 x2. What it indicates? It means what? The factors of x and x1 and x2 these are the combines both are this first order means that simple this additions means percentage of concentration of x1 and x2 what you have used is the linear equation is been used to give you the response, that is the y, the value of y you will get. But in the, if you go in the second step, y is equal to a0, suppose a11 plus x1 square, a22 x2 x square. It means what? This response is depends on this square of the factor 1. That means it is the significance of the y, value of y will be depends on what, at a very higher level. So that means the it is very highly depends on the factor x1 and x2. So in first one that will be maybe both one is not means so effective as a factors on the response. But if the equation for an x2 square, that means it is highly means effective. That means this factor x1 is highly responsible for the responses. So similarly, this type of polynomial equation which based on the equation which has been derived from the softwares is give a significant that's a particular response, whether it is the factors direct one factor is equal. So that idea you will get from the equation which will be included in the equation. Suppose this response y is equal to includes a1 equation. If you observe the equation, you will find the term if it is present x1 x2 both x2. And sometimes you will find that response is having in the equation square in the form of a square or the second type of equation in that highly responsible for that particular response. So both type is there, that is polynomial equation is give us particular effect on that particular response. So this type of equations will be based on software. So software will give you this polynomial equation, and from that one unit factor is must have is having the highest effect in that particular responses. So that idea data are we have selected that are analyzed by different mathematical models. Then the last step, the best formulation, which is the best one among this 8 or 9 formulation. If it is a 2-3 factorial design, that means 3 factorial design, it will be 9 formulations. So among this 8, 9 or 20, it can be used either the mathematical model, the numerical values. So where this Lagrangian methods of your optimize the product what you want. Suppose you should have a idea formulation which will have this much. This is the means response I want. So here is the best one. So the level of your means desirability and the software based on these comparisons of this your data analysis, the which one is come closer among all these 8 or 9 selected. So best way is to go for this source methods or graphical methods. That is the 3D means diagrams are normally used in the graphical presentation. Methods of statistics additions are used, or maybe source method, that is the computer as means assisted method. So easier way to find is the source method. So very select of documented value. So documented value means your results what you have obtained after the experiment. Value means what? That is the software based on your data. They are predict that if you use this composition, suppose composition number 3 minus 1 plus 1. So this predicted value for this particular response will be should come this much. So among these 8 or 9 formulations, the results was you have opted as a experimented value. So those formulation which match highest with predicted value will be selected. So for the beginners or the students who are doing the home or the research or not those who have not used the software, so they can go for this computer search methods by this point search methodology. So that is much easier to select the base formulation. So data representation, that means what? When the data are we analyze, then we need to represent each of the data into different form of the statistical design. 9 formulation all are evaluated. You get the response results or data. So data are will be fitted in the software. So after that, analysis will be done. After analysis, the results, ultimate results will be reflected into different types of representation of the data. So that data will be represented either in the form of ANOVA table or contour plot or the response surface graph. So ANOVA table means what? It is a based on the statistical model. So that is standard deviation, level of significance. That is level of significance, 5% level or 1% level of significance are there, or so this kind of level of significance along with the different mathematical regressions means uh, uh, results like R square value if it is more than 90% or not. So all these data will be reflected in your softwares for each of the formulations for this and for each of the responses. Suppose you have chosen 3 response, then each data you will obtain for the each of the responses. So one you will get the ANOVA table as a data, then you will get a contour plot. So that is a 2D representation of data. Means X and Y axis representation of data is called as the contour plots representation of the data. So data first we have generated and put in any of these 3 form, or you can use all of these response graph surface use. So for your understanding of this is 3D surface graph, and both are 3D. Extreme left, extreme left, it is showing the 2D contour plot. That means each of case hardness of the formulations, each of the formula software. So either if you plot it as a 2D plot, uh, or if you get 3-dimensional data, if you want, you see from this this deepest y-axis. If you consider the point of the center will be basically will give you the optimized composition, means points which is matched with the among all the formulations, which is must sometimes makes it difficulties for this means beginners to select that particular D or control code. But easier way to obtain this one is that by using this predicted value and the experimented value that will be shown in the next table. So here the data of the response for the ANOVA table. Suppose that this table is showing as an example of one response. Suppose you are selected 3 response, you will get 3 different this type of ANOVA table. So response one, suppose say hardness. So in this case, this you will get this table which includes the different column is showing the source, that is the model what is used. Model means what? Here the model, suppose in the mathematical model what you was using, whether it is a linear model or polynomial model you was selected for analysis of the data, that's model it means here. So if you select here that the linear model, that means both the term x1 and x2 linearly it will means directly it will means responsible for that response. In that time, in that cases, the response will be this table will respond means reflect in terms of your that particular selection. It is polynomial or maybe linear, whatever the model you have select. So here, if you see the model means what, that particular mathematical model, whether what you have select, the response is significant or insignificant. In the extreme right, the model significant or non-significant relative to your noise. So how it is varies, the data with your results. So depending on this results, the model will give you the significant means comments or non-significant. If it is come as a significance, you will see in the here in the last, you see residual part, it is showing the non-significant. What is the difference between this model significant and residual non-significant? What this indicate? That means the model what you have used for the data analysis, if it is significant, that means the response is having a significant differences with your that particular values. So if it is not significant, that means a model what is used, it is not fitted with the data. So here it is significant means what, the particular model or the equation what you have chosen, that was means matched with this particular mathematical model, and it is fitted well. That is why the model was given as a significant. Residual means what? All these x1, x2, xx1 or x1 square. So the polynomial equation, if you have recall that one, so they are the different term was there, x1, x2, x1 into x2 or x1 square, etc., along with the coefficient. So all these value models having the significant term. That significant means what? This x1 significant there indicates that means the factor x1 is directly responsible for this particular response. That is the hardness. That means this is depends on this particular means factor, that is x1. So if it shows significant or not significant, that means x2 factor x2 is not responsible for that particular response. So here this all term x1 model x1 x2 and xx1. So that is a linear polynomial equations is the model is significant for both the factors. So both the factors is responsible for that particular response. Here this table indicates what, the significant and non-significant term for all this factor x1 and x2. There effect is significant effect is there on that particular response. What is residual non-significant means what? That all the factors which are responsible for the response beyond that some other party. So residuals means the remaining means action. So 100% effect is not related to that factor. So related to the factor x1 and x2, but this 5% is considered as the non-significant. That means it doesn't responsible for that particular response what is showing. So here this ANOVA table will give you idea how these mathematical models are. So from here you can have the idea or you can conclude should be used and which of the factor is responsible for that particular response. So this response means ANOVA table you will get for each of the responses table, and three different table for particular each of the response terms. We need to know that my which factor is responsible for that particular response. Okay. ANOVA table, if it is showing that significant the model, that means the mathematical model you have chosen for this analysis was significant. That means direction of your study. So if it's the model comes insignificant, that means the your results responses or the factors what you have considered in the design. That means there is just some in your evaluation parts. That is why that insignificant consider or means significance means it should come the significance results when we consider using this statistical designs. So best formulation, as you say always the means among the 9, 8, or 27s, which one is the best one. So how to select this one? So that selection of this one basically is depends on what each of the response. Suppose you will have the three response R1, R2, and R3. So here from the statistical software, you will get the value of experimental value and the predicted value. Experimental value means what? This is your own value, what you have evaluated after the formulation. Of formulation, suppose you have run 8, if it is there, what is the composition of run 8? Or according to that, you have formulated, then you have evaluated. So you have got the evaluation result and the experimented, it is percentage drug loading 80, bioadhesive resistance 76. When we feed the data, all experimental data in the software after analysis, they used to predict that you have used the factor level this one and data what you have used according to the means the model fitted into that software, they will predict some value. So predicted values are given here 81.23, 78.22, 80.01. So for each of the response, you will get the predicted value. For each of the formulation, this is suppose showing for the one formulation number 8 or run 8. So we need to compare these two. And you can have a plot of these two predicted value versus the experimental value. So when you plot for each 9 of the formulation or 8 formulation or 27 formulation of your experimental design, so you will have to plot this one experimental value with predicted value. So which one the regression equation which comes closer to 1, nearest to the 1, will be the best, will consider as the best formulation. So in this case, this table is I have shown that this result is means very much closer to that predicted result and the experimental result. So we can consider the run A is the optimized formulation of of our experiment. Experiment what we have done. So this way normally we select the optimized formulations from the by using the statistical software. And until we use this kind of software or this, the data or this justification is not accepted by the scientific means community. So this experimental data should always be means evaluated by using the statistical software. So one of the software which we use basically is the design expert. So there are many other softwares which are available in the markets for analysis of this data. So this here uh, are basically the design experts that Systat, Sigma Stat, Systelist, Minitef, Matrix, Compact also available to analyze in this kind of data. pharmaceutics we normally use basically this Minitab or design experts is commonly used software for this selecting. So in this way we can experimented design experiments. The base purpose here only we have used 3 to factorial design. That means 9 formulation we have selected. So if you do not go for this, do not go or do not use this structure, in this case you will have a lots of option. You can use suppose a different concentration because your response will be depends on the few not systematically design the experiment, then trial now obviously your time consumptions of the experiment is more. So wastage of money, chemicals, standard statistical design, so that we can minimize the number of trials is performed. So do not use that means these data are not scientific or systemic. So in that case, acceptability of the results is very poor. So when it's published or maybe scientifically established, you need to go for a systematic evaluation means for this optimization process of pharmacy. This means statistical designs or is helpful for time savings or this cost savings or maybe this this level other means all other number of trials will be reduced by using this statistical software will help us to minimize the cost of the product as well as it will give you the highest means values of your product, so in a proper or systematic manner. So this is the pyramids of statistical optimization. If you see from the top to bottom, so the order of your statistical design in systematic manner can be means represent in this way. That is first step will be what study the need of design and selection of variables. So that is the first step in the beginning of your study. You need to know what is your objective or your that aim or maybe goal, and how to achieve this goal. What are the means variables you will be select. So variables mean that there will be 2 variable. One is constant, another is the unconstant. So one is dependent, another independent. So what is independent variables and what is dependent variable? So that first you need to select that one. Once you select the independent variable, you need to use what is the concentration of or the limit of the independent variable you are going to use for each of the factors. So that is need to be to meet the different responses. Response means that is the objective what you want to taste for your experiment. So that response you can choose according to your own way. So first step, that is the selection of the variables, and that is dependent and independent variable. So that is the first step. Second step is design of experiment. So now you will design the experiment in whether it is a factorial design, whether it is a factorial design, whether if it is factorial design, whether it is a 2 3 factorial design or 3 2 factorial designs or 3 factorial design. So this way you depend, that is depends on your number of means factors you are have and what are the number of variable you want to taste. So depending on that you can choose. Suppose it is a 2 3 factorial design, that means 3 is your factors. 2 will be your concentration. So the 3 factor x1 x2 x3 level may be low and high. So if you have this one, so you can use 2 3 factorial design. Suppose no, I am having 2 factors, that is x1 and x2 or x and y. So but I want to have both the factor x and y at 3 different level. So that is the case, what you can do, you can use 3 factorial design. So that is high, low, and medium. So that is -1, 0, 1. So in that case, you can use 3 to factorial design. So if you want, suppose say 3 factors, 3 means levels, so you can use 3 factorial design. So that is depends on how many factors you are having, what are the levels you want. So accordingly, you can use your design. So designing maybe if you can choose by the formulator themselves. So depending on the number of factors and variables they have in their options of the research. Okay, so that is design of experiments. So that can be select either by the factorial design of any means the designs or central composite design. So central composite means this limit beyond the limit also some point or the formulation need to be considered in that case. So that's a box which should be if you want to consider. So that gives the of the factors. There will be 2 additional term and 6 means the numbers of additional composition plus 1 to perform. So that way central composite decides is you will formulate the your formulation, then you data generate the data. So this data are basically what this is the experimental part. Formulate you need to apply it in the statistical software. So where the data are fitted, then function what mathematical model will be selected, whether it is a linear, will be selected in the software. Then software will be results. So results are reflected in terms of 3 different form. So I have said dimensional data, 2D data, or maybe 3D data. That is the response star that will achieve to the goal, that is by using either or that is computer generated methods. That is the ultimate goal of the formulation. So this is considered as the pyramid of statistical optimizations, where we get the ultimate goal. Means goal can be achieved by systematic manners by designing a design of experiments of your research. So this is all about your means this optimization of pharmaceutical formulation using statistical software. So if you have any doubt, any queries.
Thank you, sir. Thank you very much, sir, for your magnificent presentation and enlightening us with your knowledge and experiences. Sir, I'm sure all the students and faculty members have benefited from your wonderful lecture. Now, sir, we move on to the question answer session. Sir, can we take the fast questions?
Yeah, sure. Great. What is the question?
Sir, first question is how can we make a difference between interaction and curvature effect?
Interaction and curvature effect.
Curvature effect, yes, sir.
So
How
this
can we
curvature,
yes.
yeah, interactions means what? When you are having, suppose you are having a factors, different factors, okay, factors x1 and x2. So in this case, whether both the factors have the responsibles with that particular response or not. So where if this hello. So then the curve of your interactive curve will meet at a certain points when will which will indicate that that particular means points these both the factors is having the effect. Okay, and that the interaction points basically is drawn for the individual factors. And the curvature basically what this is a three-dimensional curve where the means 3D means effect of each of the formulations is drawn. Okay, so which give a deepest points where the maximum effect is reflects. So this is the basically difference between this interactive actions and this curvature point.
Okay. Thank you, sir. Thank you everyone for your valuable presence and magnificent presentation. Sir,
Yes.
stay safe and have a nice day ahead. Thank you, sir.
Thank you. Thank you so much. Thank you everyone for listening this webinar. Thank you everyone. See you. If you have any kind of problem, you can please contact me at 985404656.
Okay, sir. Thank you, sir. Thank you so much, sir.